Hello everyone and welcome to the third tutorial in the series about CMOST. In the first tutorial, we learned about sensitivity analysis, how to find the parameters that influence the production from a reservoir. In the second tutorial, we learned about history matching, how to find the parameters that match the data that was recorded in the field. And now in this tutorial, we're going to learn about optimization, how to use our new and more matched model to go and optimize the production parameters, how to find the parameters that will lead to the highest production from the reservoir, such as where to put your injection well, at what level of Gasol Ratio or what level of water cut should you stop producing from a well and shut it in. So we're going to learn how to find out those parameters in this optimization tutorial. So let us get going. So go and find the link. You'll need some data for this tutorial, so go find the link in the description below the YouTube video. Go and open that up over here. You'll see this box and click on download. Okay, it's taking some time to download, beginning shortly, and there it is. Perfect. Should take a few more seconds and we should be ready. Perfect. So now let us go and show that in the folder. Let's extract it. Extract all. Extract. Perfect. There we go. I'm going to go click on Control-C and put it in Documents. There we go. It is now in my documents. Now, the next thing that we're going to do is that we are going to go into Launcher. So right over here, we're going to go and find where that is. Let's maybe we'll need to do some refreshing. Okay, so we're looking for CMOST Optim tutorial, and here we have two sets of files, and we're going to first look at the ones that we're mainly going to be using are this IMEX tutorial, prediction of water, add wells modification. We're going to go here and open it in Builder. Perfect. So let us look what we got here. We have here a reservoir, and we have a lot of wells in here, and we can see that by clicking on over here. We have several producers, well 1, well 5, well 7, okay, and we have some injectors, infill injector 1, infill injector 2, infill horizontal producer, and we're going to try to find out how to optimize where to locate these infill injectors and the infill producers as well, such as this infill horizontal producer. That's going to be one of the tasks that we do in this tutorial, as well as this well 16 injector and well 5 injector. Those are options where we say, let's take well 5 and well 16. Let's think, should we or should we not convert these producers to injectors? Interesting question. Before we move on, let us take a 3D view of this so we get an idea of the 3D dimensionality over here. We're going to right click and then click on Rotate 3D View. Okay, so you're getting an idea. Oh, this is fancy model. Perfecto. Now let us go to CMOST. Okay, no need to save this. Fine. Little error, doesn't hurt anyone. Let's open CMOST like this and get going. Okay, so let us expand and make a new project. And let's call this Infill Well Optimization. Perfect. Let's browse for this file. And we're going to be using this modification one. Okay, perfect. Accept it. Now we're going to make a new study and give it a fairly similar title, and just infill, capital, why not, infill optimization. Perfect. Let's go and choose the same file that we did before, and this is going to be an optimization. So we're going to go click on OK. It's taking some time, but we are good. Infill optimization. Let's click Save. Always good to save in life. Okay, let's first start, and this is kind of an outline of our workflow. We can do fundamental data, parameters, objectives, then controls. So let's start with fundamental data, and here we're going to be telling CMOST what are the parameters that we're interested in looking at. And we're going to put in 6 values over here, and they are going to be by sector. So let's just quickly do this by sector. And by sector is what you defined previously. In our case, it's just the whole well field. Okay, let's go into here and check the entire field for all of these. Almost done. Perfect. So for property, we're going to choose oil recovery factor. Oil recovery factor. Next, we're going to choose oil production cumulative. Perfect. Next, we're going to choose oil production rate. Next, we're going to choose water injection rate. There we go. And actually, water injection, let's make that water injection cumulative. There we go. Now, water cut per sector. Last but not least, the gas-oil ratio. And what we're seeing here and below, gas-oil ratio, okay, is the initial values that you get from the baseline, which is the model that we input here in the beginning. To run CMOST, you have to have at least one model that you have already ran completely, and this is the results of that model. This is the baseline before we did any optimization. Great. Now, not all the values you would like to follow are in here, so we might want to add another user-defined time series for time series that we're interested in following. And we're going to insert here 2 time series that we want to look at. Actually, just one. And that is going to be the voidage replacement ratio. Okay. And we're going to start this, looking at this from 2010-03. Perfect. And the way we're going to make this, so instead of every column date point, let's do it every month. Perfect. And the way we're going to calculate this is via 2 parameters. The water injection rate. So, and we can go here by sector, entire field, and then water injection rate. And we're going to add one more thing, and that is the liquid production rate. Oh, production, and let's see, liquid production. There we go. And what this parameter is, now we're going to give a formula that we're going to calculate, and that is going to be water injection capital there, divided by liquid production. Perfect. And we're going to click here on check this out. Oh, there was an error. It couldn't find water injection. So we're going to go over here. Oh, and I actually called it water inject. So that's good that I checked. I'm going to correct this. Now let's use this button again to debug, and we see that we get a value. That is perfect. Now, next thing that we're going to do is go and make the parameter file. So I'm going to go click here on parameters. Now, usually you can input the parameters one by one, but in this case, we're going to do it via cedit. Okay, and this is the main document that CMOST uses to determine what are the parameters it's going to vary in order to optimize the field production. Perfect. Now, let us get going, and we are going to search for date 2010-2. And we're going to change here several things. So right here we see that it's monitoring this well 16, and when it gets to certain oil production, or below a certain oil production, then it's going to shut in. Or when it gets to below above a certain gas-oil ratio, it's going to shut in. Or above a certain water cut, it's going to shut in. But we're not sure these are the right values. We want to check these out. So we're going to make a new parameter for them. So we can do right here, create parameter, and we are going to call it min oil rate. So min oil rate. Perfect. Now we see we added that CMOST parameter over here, and now it appears as follows. Now, we do not know about the gas-oil ratio, what should be the maximum, so we go here and we create a new value, and we're going to call it max GOR. Didn't type in. Max GOR. Perfect. And we're going to make one more, and that is over here at 0.95. We're not sure. Again, we're going to create a new parameter, and we're going to call it max water cut. So max water cut. Perfect. Now we don't want this to be only for this well 16. We want to make for all of the production wells. So I'm going to highlight this, 3 lines, and do Control C. And what I'm going to do here is a little trick. And I'm going to go click on these 3 lines here and do Control F. Quick find and replace with. Let's see if this even works. Let's see, replace. Okay. Maybe not. It's not working. Okay, you can't do it with the 3 lines. So instead what we're going to do is just highlight these 3 and do Control V. And let us do that again for each one of these wells that are production well. Okay. A little bit tedious, not too bad. We're going to get through it nice and quick. Okay, a few more to go. Great. Now there is one more actually that we have to find, and that is the horizontal one, and that one is called, actually, yes, infill horizontal producer, and let's find it. Let's find its monitoring criteria, and there we go. Switch that. Okay, let's click on save. So I just did Control S. Next thing we're going to do is we're going to locate the text that says shut in well 16. Found it right there. Now we're not sure whether we want well 16 to be an injector or a producer. So this shut in, we're not sure whether to be shut in or just open. So we're going to go right click here on where it says shut in and make a create parameter. And we're going to call this parameter well 16 status. Well 16 status. Same goes for well 5. We're not actually quite sure about it. So when it says here shut in well 5, we're going to create another parameter. And we're going to call this, instead of shut in, we're going to call it well 5 status. Oh, and I just did this one a bit differently, so let's change that. So it's the same style. Well, okay. Perfect. Now, next thing we're going to do is we're going to find the text for open well 16. Okay. There we go. And right over here, what happens is that we're opening well 16 injector. Now, we're not sure whether we want well 16 to be an injector or producer, so this open might actually be shut in. So by default, we have an injector as we have well 16 shutting in and turning into an injector, and it's opening at this point. We're not sure if we actually want to do that conversion process. So we're going to go click on this open, and we're going to create a new parameter, and we're going to call it well 16 injector status. Okay, and same goes for well 15. So let's go and find open well 5. Not 15, mistake. Okay, and again here we're going to do the same kind of thing. Create parameter, and this is going to be well 5 injection status. Perfect. Very good. Okay, now the next thing that we want to look at is whether our current location that we have by default for the horizontal infill production well is a good location. Maybe we'd like to move it around a little bit. So we're going to go search here for the infill horizontal producer. And right here in the definition, we see that we're putting in IJK of 5 and 17. But maybe we don't really like that. So we're going to go here and highlight 5. Oh, and create a parameter. Now see, you didn't really quite catch it, so I have to do a better job of right-clicking without the highlight going away. Okay, so we've gone and we created a parameter over here, and we're going to call it infill horizontal producer J. Perfect. Let's just capitalize that. Okay. Next thing that we're not sure about is even about the K for this. Okay, so we're going to go here and right-click on it, and we're going to give it a very similar name, infill horizontal producer K. Perfect. And then we're going to go over here, and we're going to copy this whole thing, because we want to make sure that the value changes for each one of these lines. We don't want one of the lines to be a certain value and some of the other lines to not be a certain value. Okay, so just highlight this, and copying, and I'm almost done. Perfect. And actually it's right here below. Also for the infill injector that is not horizontal, the vertical one, we are not sure about the location on the I and j coordinates. Maybe it should be a different one. So I'm going to right click here on 34, and I'm going to create a parameter, and I'm going to call it infill injector 1 I. Good. And here I'm going to call it very similarly. Ooh, my right clicking abilities are. There we go. Infill injector 1 J. Great, great. This is looking nice. And I'm going to copy this. And this time I'm going to get a bit lazy probably, and I'm going to go and try this trick again. You Control F, quick replace, and delete that, and put this here. And then I'm going to see if I can replace that automatically. And I can, which is great, makes this go much faster. Okay, next thing I'm going to do is the same thing for the infill injector 2. So I'm already just going to highlight these two, put the same thing as before, but I'm going to change this parameter name to be injector 2. And also, this shows you the default values. The default value is actually 30 and 33. Perfect. And I'm going to do the same thing as before in lazy spirit. I'm going to copy paste this. And I'm going to highlight this, do Control F, quick replace, remove this, put this new thing here. And then automatically fill this up. That is great. And so now we can see that instead of an actual value here, we have a parameter. That is infill injector I and infill injector 2J. And we'll then be able to change these parameters to go and optimize this scenario. So the next thing we're going to look at is right down here, and that is the injection rate. And we see that for all the injection wells that we're putting in there, and we see that it's 5,000. So I'm going to go and change that right here and make out of it a parameter because I'm not actually sure what is the right injection rate. So I'm going to go and call this group injection rate. Perfect. Okay, now let us go and click on save. I think we're done making these parameters, which is awesome. Let us go over here and close it and do import. And all these parameters have just appeared here magically. That's just wonderful. Okay, now that we have all these parameters ready here in the parameters table, we need to give them ranges of values that we are going to vary in order to find the values that give us the best production from the reservoir. So we're going to start here with group injection rate. Now the default is 5,000, but who knows? Maybe it could be higher, maybe it could be lower. So we're going to give it values of 1,000 to 7,500, and we're interested in finding which one in between this given range is the best value. Okay, then these next values are all I, j, or k coordinates, meaning they're discrete. It's a grid, so it can only be a discrete real integer. So I'm going to go here, discrete integer, and change all those to discrete integer. And the way that you would find out what are reasonable values is you would have to look at the grid. Of course, a non-reasonable value, for example, would be a value of j that is off the grid. Okay, so we're going to generate values for here. So by default, it is a value of 5, but we're going to say it can be anywhere between 3 and 9. And between 3 and 9, that's 9 minus 3, 6 plus 1, so that's 7 values in between 3 and 9. Okay, and then we generate those values. Then we're going to go to k, and we'll generate values for that between 5 and 18. So we go here, 5, 18, and that's 13 plus 1, that's 14. Okay, perfect. Next, we're going to go here to the infill injector 1I location, and we're going to generate for that. That is going to be between 31 and 38. So 31, 38, and that's going to be 8 values. Okay, the next one is the j coordinate. That's going to be between 2 and 8. So let's go and generate that. 2, 8, and that's going to be 7 values. Next one that we're going to generate for is for the second injector, the I value. So we're going to give that a range between 25 and 35. 25 and 35. And the number of values there is 11. And last one in terms of coordinates, we're going to generate between values of 27 and 34. So 27, 34, so that's 7 plus 1, that's 8. Okay, perfect. Now we're getting to the max gas-oil ratio. And this is the gas-oil ratio. When it goes above this, then you're saying we're going to shut in. Okay, so then we have that value between 400 and 1500. Oh, there we go, 1500. Now the next one that we're going to set up is the max water cut ratio, and we're going to make it between 0.75 and 0.995. Great. Next is the minimum oil rate, and that is going to be between 0 and 5. These are the rates at which we say, okay, just shut in the production well. It's not worth the effort anymore. So let's go and look at well 16 status, well 16 injector status, well 5 status, and well 5 injector status. Now the behavior that we want is we're not sure whether well 16 and well 15 should be injectors or producers. So what we want is, for example, in the default scenario, we have that at a certain time, the well 16 is shut in and well 16 injector is open. So it's basically the same well, it's changing its injector status. So by default, it's, in the base case, changing into an injector in the middle. So the way that we can do that is we're actually going to create 2 new parameters. So insert, and then another insert, and we're going to make these a discrete integer that can take a value of either 1 or 2. Okay, so discrete integer. One is the well is open, the other one is the well is closed. So this is going to be well 5 type, where in 1 it's a producer, in 2 it's an injector. And this is going to be well 16 type. Great. And we're going to give this values between 1 and 2. So between 1 and 2, 2 values, good. Now here you're going to generate values between 1 and 2, 2 values. Perfect. Great. And I'm going to give this, by default, this is a value of 2. Okay, that's what it should give. That's what we have it right now. Okay, and now what happens is that the well, for example, well 16 status, we're going to go on and see here actually formula that will be controlled by that new parameter that we just made. So let's change all of these to formula. Okay, so well 16 status is going to say look up the parameter well 16 type, which is taking values of 1 or 2. And if it's 1, then you give it a value of open. And if it's 2, you give it a value of shut in. Great. Now let us practice this. So when you go like this, it says it's shut in. So by default, the producer is shut in, which is correct. So let's actually copy and paste this to save us some typing time. We go here into well 5 status, and the same thing, we just change here this into well 5 type, and it should again be shut in. Great. Now for the well 16 injector status, we want it to be open. So the only trick that we're going to do here is we're going to switch the order of 2 and 1, and it should say that it's going to be open. Great. Now let's copy this and put it into the well 5 injector status, and we see here, just change this. Bam, bam, perfect. Open. Okay, so good job, guys. I think we are done setting up these parameters, which is great. A cause for saving and celebration. Now let us move on to the objective functions. First thing first, we're going to set up a characteristic datetime that we are going to be using later on. And we're going to call it forecast start. And I'm going to set it to a time of 2010, February. Perfect. Great. Okay, and we are going to insert over here our first time series that we are going to be following, and that is oil recovery factor. And we're going to make this a sector and entire field, and we're going to give it a property of oil recovery factor sector. Perfect. Now we're going to set up the net present value, which we're going to use for optimization. So we give it a name, the default is fine, field NPV, we're going to give it a unit, which is dollars, what we care about, and we're going to put in here two local NPV definitions. The first one is going to be oil revenue, and that is how much money are we making from the oil production side. So we can go here, and we use as a base case start, we use the forecast start, which we just set up in the characteristic date times. Great. And now how do we find out? How do we define what is oil revenue? So we're going to choose one of our wells, that's the producer, and we're going to go look at oil rate, and we need start time as the forecast start. You have your keep the default discount rate, and we're going to say, well, how much money are we making per barrel? And here's $60 per barrel, and then we're going to say, okay, what is the conversion factor from meter cubes to barrels? And we have 6.28981. Great. Now we're not interested right now. If we would leave it at this, it would make oil revenue just how much production there was from this infill horizontal producer times the conversion factor, turning it into barrels, and then times $60 to barrel. But we actually want it from all the production wells. So we're going to go here, and we're going to choose all of the production wells. Oh, not the injectors, just the producers. Okay, so that's basically everything that does not have injector appended to it. Okay, great. You can click on OK, and that just made copies, but changing the origin name. That is awesome and quick. So the next thing is that we need to find out not only how much revenue we're making, but also how much money are we spending on this injection, which we're going to subtract from the oil revenue. And that is the water injection costs. So the water inject cost. Okay, and what is that going to depend on? Like you would think, it depends on the injectors. So you go here and click on this infill injector, and then we're going to go and click on water rate. Water rate, and forecast start, yearly discount rate, and here the unit is actually negative. We're making how much values each unit, giving us negative 0.5, and we have to convert it to barrels. So that would be 6.28981. Great. And like before, we're going to click here then on repeat, and we're going to choose all of the injectors. And I'm using the control button, by the way, to choose the wells I'm interested in. Right, so what this NPV does, just to cap up, is that we defined an NPV, which is the summation of the oil revenue and the water injection cost. But the water injection cost is going to be negative because we gave it a negative unit value. And we want to optimize this overall sum over all the wells, the producers, and the injectors. Great. Well, we could have stopped here in terms of the objective functions, but we're actually going to try one more objective function just to get practice in it, and that is the advanced objective function using an Excel sheet. So we can click here, use Excel spreadsheet calculation. Now this is good because many of you maybe have Excel sheets that you can use to do fancier calculations than what we saw previously. So I went and I clicked this NPV calculation Excel sheet that is ready for this tutorial and should be in your data files. And what this does is it is an Excel sheet that takes in data from CMOST, for example, the cumulative water injected, the amount of oil produced, and then it does a lot of calculations to find out the final NPV, which puts here in the L1 box. So we're going to put some data here in C6 and D6, and then it's going to go and calculate the NPV. Then CMOST will take this value of the NPV and use it for the optimization procedure. So the worksheet name is called NPV, in case you didn't notice. And like we said, the data that we're interested in is in L1. That's where the NPV, as you saw here, that's where it's listed. Okay, so L1, and that should pop up right over there. Great. Now we're going to write time series data to Excel, and that's going to be those two columns that we saw previously. And that is by sector, entire field, and okay, great. Okay, and then we're going to go and look at over here, the oil production cumulative. Oil production cumulative. Oh, there we go. And we're also going to look at the water injected cumulative. Okay, every month, worksheet name is MPV, and here we got the start column name is B, start column name is C. Okay, and that should put in, oh, we didn't put here the reference start cell, which is 6. Oh, not 65. Oh, there we go. Perfect. And I think we just have to give this actually a more formal name. Let's call it MPV Excel. Now just let's test that. Oh, also do not write the time array because we already have the time array in there. So we can click here on test. Let's see if it gives us a value. And we see it gives us a value. That means that's working. It's great. So we're not actually going to use this for the optimization, but it's good to know how to use it. Okay, so we just finished this objective function. Give yourself a high five for good behavior. Now let us move on to this engine setting. Guys, you are almost there. So our study type is optimization. Okay, we have the engine name here. Now there could be several other engines, random brute force, Latin hypercube. We're going to keep it to the default. Okay, we just have to choose here our objective function. We're going to use the field MPV that we defined. But you can see we could have also used MPV Excel or any other one. And of course, we do not want to minimize, rather we would like to maximize the MPV. Perfect. Now the next thing that we're going to go is to simulation settings. I'm going to choose local. Most computers have around 4 cores in them, which allow you to do 4 concurrent jobs. And then we go here into the experiments table. You see it has a little X next to it. Why? Because one of the experiments is waiting to be reprocessed. So we are going to click here on resolve selected experiment. Yep, I'm going to keep it at the default value of 2 because that's what the default was. And click on save. And it seems like we are ready to go off. So let us go to the control center and then click on go. Hopefully no errors. Let's see if we are lucky. Okay, showing us the scheduler. Click OK. And it is starting to get off. Let us just wait for a moment and see that it actually makes one of the simulations sent to the launcher. Okay, well, it seems like it is working, so I'm just going to let it stop right now, actually, because I have already ran this for us, so we do not need to wait. Isn't that wonderful? No waiting necessary. Okay, so I'm going to go open here. The completed runs, almost done doing 500 of them, so even this one is still running. It's been going for 4 hours. So you guys can say thank you. You guys do not have to wait for this. And wow, what we can see here is the field MPV for different parameters. We see that the base case is around here of 5e to the $8. And we see that just changing the parameters around, you can increase the MPV by a significant amount, which is why it is important to do simulations and to look at the different parameter possibilities. Okay, so that is ID number 276. So let us go and take a look at the parameters that yielded that high MPV. So we can scroll down here. Maybe we can go a little faster. Oh, past it. Almost there. Okay, there we go. There it is, 276. Okay. I actually just gave it a rating by accident. That's fine. It should get more than 3 stars. We see here is that this is indeed the optimal one. And we can also see what are the different parameters that led to having such a good result. And then we can use that in the actual field, which is the whole point of running simulations. So you can see here the infill locations, the maximum GOR, the maximum water cut, the minimum oil rate. All those values are here. That is wonderful. Let's say you want to get more of intuition and not just one value. So we would go into this objective function over here. Then we can go into proxy analysis. In proxy analysis, we would look at field MPV. Okay, and we can see here different kinds of analyses. Okay, what is important? The group injection rate, important. Maximum water cut, important. Okay, we kind of see very similar insights over here in the MOST analysis. If we look at the effect estimates, we can get an idea about the directionality. So that, for example, we see that increasing the group injection rate increases the productivity, even though it actually costs money to use all that injection fluid. It seems to pay off. On the other hand, if we increase the water cut, then we decrease the production and NPV of the system. Let's say we want to get a little more intuition than we see here. We go to the cross plots and then to the NPV Excel. Okay, sorry, I meant field NPV. Now I've already gone here and made these. But if I go here, all you have to do was click on select, make these parameters, and then click on OK. Now I've already set about here to find one of the more interesting plots that we see here. And what we see is that at a value of 1 of a maximum water cut, at which point you shut in the wells, you get a fairly low field NPV. And a maximum water cut that's too low, you get a low NPV as well. So the whole idea here is that we see that the best case, which I accidentally gave to 3 stars, should be 5 stars, gives us a maximum water cut around 0.86, or in general any of these high values, these medium values, will give you a high field NPV. So this is good because this gives you an intuition. You don't just get a number, but you see that this is not a one-off thing. It's like an overall trend. And you can also move and scroll around here with the different things and try to see if there's any sort of pattern that you can make out. Okay, so it seems like usually only the sensitive ones will show a very clear pattern. Other ones will be a little more random. Okay, so it seems like we just reviewed some very important things. Last thing that you might want to look at is take a closer look at the results. The way you would do that is like we did before. You go back to the experiments table and you'd find that optimal experiment, and now it's highlighted already, so you can actually go over here and already click on launch results, and it will launch those results for you. Okay? And then you can look at this both in terms of 2D and in terms of 3D. You can go here into into time series, for example. Into time series over there, for example. And you can go and you can look at different wells and different aspects of them. You know, cumulative oil versus cumulative gas, cumulative water. Okay. And then add to new plot. And then you can get some more detailed information about what happened. You can also go and look at this in 3D. Okay, look at a nice 3D map. Makes good presentations, of course. And go and choose here different parameters. Pressure is a good one, actually. And you can see it changing over time by using this slider. Very colorful, very nice. Well, let us go over what we did in this tutorial before I say goodbye to you guys. We looked at some fundamental data. Then we looked at the parameters and used CMOST to define those inside the file. Then we went and defined our objective function. After we had the objective function, we went to the engine setting and said, look at this objective function. It's the NPV. I want to maximize it. Find the parameters that will maximize this for me. Okay, we are done. Thank you so much for listening to this tutorial, and I hope it helps you in any of your projects, research, company, anything. Have a great project.